Hello everyone. Today's topic is Laplace transform and inverse Laplace transform on derivative. So on left hand side I am writing Laplace transform on derivative, and in right hand side I am writing inverse Laplace transform on derivative. Clear? So first Laplace transform on derivative. So obviously here the function f of t that will be given, and obviously you can calculate f of s. So if Laplace of f of t, this is equals to f of s, then Laplace of, we have to calculate Laplace of the derivative term. So Laplace f dash t, this is equals to, simple, just you have to multiply s with f of s. So s into fs, okay, minus f of 0. Okay, here you can see that this fs, this is small fs, but this is capital F of 0. Okay, here fs, small fs, that means the Laplace transform of f of t. Okay, but here f of 0 means you have to put t equals to 0 in f of t. Clear? This is the difference. So s fs minus f of 0. Clear? But here you can say the given function, this is only single derivative. But suppose we have a function where the function is 2 times derivative, 3 times derivative. Okay, so in that case Laplace of f double dash t, this is equals to, very simple, s square fs minus s f of 0 minus f dash 0. Okay, so you have to multiply s square, then the power of s, that will be decreased by 1, and also the derivative of f of 0, that will be increased by 1. So f of 0 then minus f dash 0. Suppose triple derivative, so Laplace of f triple dash t, this is equals to, so that will be obviously s cube fs minus power of s, that will be decreased by 1. So s square f of 0 minus s f dash 0 minus f double dash 0. Clear? So what will be the in general formula? So Laplace of f n t, f n t means n times derivative. So this is equals to s to the power n fs minus s to the power n minus 1 f of 0 minus s to the power n minus 2 f dash 0 minus dot 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 last one, that will be here you can see, when single derivative last term is f0, double derivative last term is f dash 0, triple derivative last term is f double dash 0. So obviously when nth derivative, so last term will be f n minus 1 0. Clear? This is the formula. But remember, just you have to apply these two formulas. Okay, if you are given double derivative, then you have to use the second formula, and for single derivative you have to use the first formula. Clear? Now for inverse Laplace transform, the formula is very simple, and let me tell you, in inverse Laplace transform you cannot calculate applying inverse Laplace operator in this result. Okay, so you have to remember the formula. So in inverse Laplace transform, so obviously if Laplace inverse f of s, this is equals to f of t, then Laplace inverse of f dash s, this is equals to just minus t into f of t. Okay, minus t into f of t. In general, Laplace inverse fns, okay, in general Laplace inverse fns, this is equals to minus 1 to the power n. Here s is nth time derivatives, so minus 1 to the power n, you have to multiply t n times. minus 1 to the power n t to the power n into f of t. Okay, this is the general formula for inverse Laplace transform. Okay, remember, in inverse Laplace transform, all these terms f of 0, f dash 0, f double dash 0, that will be 0. Okay, so when you are calculating for first derivative, f of 0 will be 0. When you are calculating for nth derivatives, in that case, f of 0 equals to f dash 0 equals to f double dash 0 equals to dot 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 f n minus 1 0. All the terms will be 0. Okay, this is for inverse Laplace transform. Okay, now let's solve some problems using these derivative formulas. Question: find inverse Laplace transform of log of 1 plus s divided by s. Find inverse Laplace transform of log of 1 plus s divided by s. Actually, in this question, you cannot understand that you have to apply derivative formula. Yes or no? Because there is no standard pattern in derivative formula. For example, suppose in scale property, we know that if the variable t is multiplied by a, we can use scale property. Similarly, in fast shifting property, we know that if the function f of t is multiplied by exponential, we can use fast shifting property. But in derivative formula, there is no standard form. But remember, suppose here the question is in logarithmic function. Okay, but we don't have any formulas for logarithmic function. Okay, in that case, we can use the derivative formula, because if suppose in this question f of s equals to log of 1 plus s divided by s, and if we derive it, so that will be 1 by 1 plus s minus 1 by s. Then on the, so that will be f dash s. Then on that function f dash s, you can use the formula of derivative. Okay, let's solve it. Solution. So obviously here f of s is equals to log of 1 plus s divided by s. So you can write this is equals to log of 1 plus s minus log of s. Clear? Okay. Now, what will be f dash s? F dash s equals to 1 by 1 plus s minus 1 by s. Now apply Laplace inverse on the function f dash s. So Laplace inverse f dash s, this is equals to Laplace inverse of 1 by 1 plus s minus Laplace inverse of 1 by s. And you know what is the Laplace inverse of 1 by 1 plus s? This is e to the power minus t, minus Laplace inverse of 1 by s, this is 1. Okay. Now, according to the formula of Laplace inverse of f dash s, we know Laplace inverse of f dash s, this is equals to minus t into f of t. Yes or no? Here question is Laplace inverse log of 1 plus s. So this is our f of s, and you have to find out Laplace inverse of f of s. That means actually you have to find out f of t. Yes or no? We have calculated f dash s and we have calculated Laplace inverse of f dash s, and this is the result. Now, if anyhow we can arrange this result e to the power minus t minus 1 in this form, minus t into f of t, then comparing these two results, you will get f of t. Yes or no? And this is our main target. You have to find out f of t. Okay, so let's write this result e to the power minus t minus 1 in this form, minus t into f of t. Okay, so first take common minus, so that will be 1 minus e to the power minus t, and here t is multiplied, so let's multiply t. So minus t into 1 minus e to the power minus t divided by t. So obviously if you compare these two results, you are getting f of t, this is equals to 1 minus e to the power minus t divided by t. Okay, so this is the result. So you can say that Laplace inverse of log of 1 plus s divided by s, this is equals to 1 minus e to the power minus t divided by t. This is the final answer. Clear? Okay, so remember, first you have to calculate the f dashes, then apply Laplace inverse of f dashes, and then compare with the standard result of Laplace inverse of f dashes, and you will get f of t. Okay, let's try another problem, almost a similar type, actually exactly similar type problem. Okay, so question. Find Laplace inverse of log of s plus 6 divided by s plus 2. Okay, so obviously here f of s is equals to log of s plus 6 divided by s plus 2, and you can write this is equals to log of s plus 6 minus log of s plus 2. Okay, now calculate f dash s. So that will be 1 by s plus 6 minus 1 by s plus 2. Okay, now Laplace inverse f dash s. So this is equals to Laplace inverse of 1 by s plus 6 minus Laplace inverse of 1 by s plus 2. So this is equals to, this is e to the power minus 60 minus that will be e to the power minus 2t. Okay, now you have to write in the form of minus t into f of t. So you can write minus e to the power minus 2t minus e to the power minus 60. Okay, now minus t into e to the power minus 2t minus e to the power minus 60 divided by t. Obviously this result, this is your f of t. So f of t, this is equals to e to the power minus 2t minus e to the power minus 60 divided by t. Okay, so in final answer you can write Laplace inverse of log of s plus 6 divided by s plus 2. This is equals to e to the power minus 2t minus e to the power minus 60 divided by t. Okay, this is the final answer. Okay, let's try another problem. Question. In this question, you are given f of t. Okay, f of t is equals to e to the power minus 5t into sine t. This is given. Okay, and you have to find out Laplace of f dash t. So first calculate Laplace of f of t. Okay, and you will get f of s. So here sine t. So first calculate Laplace of sine t. Laplace of sine t. This is equals to 1 by s square plus 1. Now let's calculate Laplace of e to the power minus 5t into sine t. So obviously here exponential is multiplied. So you know when exponential is multiplied, you can apply fast shifting property. So that will be 1 by, here the value of a is minus 5. Yes or no? Here the value of a is minus 5. So you can write s minus a. Okay, let me write the fast shifting property. Laplace of e to the power at f of t. This is equals to f of s minus a. This is the formula, fast shifting property. That means in place of s, you have to write s minus a. And here a is equals to minus 5. That means in place of s, you have to write s minus minus 5. That means s plus 5. So s plus 5 whole square plus 1. Okay, so this is equals to 1 by s square plus 10s plus 26. Clear? So what is this? This is the f of s. Okay, this is your f of s. Now you have to calculate Laplace of f dash t. So Laplace of f dash t, this is equals to, according to the formula, s fs minus f of 0. Now what is f of 0? Actually f of t, this is equals to e to the power minus 5t into sine t. Now what is f of 0? That means you have to put t equals to 0. So that will be e to the power 0 into sine 0. And you know sine 0 equals to 0 and e to the power 0 means 1. So 1 into 0, 0. Okay. So the final answer is s into fs. So s by s square plus 10s plus 26 and f0 is 0. Okay. So this is the final answer. Okay. I think the application of Laplace and Laplace inverse transform on derivative is now very clear. Now try to solve your textbook problems. Thank you so much.